Good morning, friends. Today we are going to discuss scales. So, last video we discussed epicyclide, simple cyclide, and hypocyclide. And with this, we can end this first unit. So, in these scales, we are going to discuss plane scale and diagonal scale. So, vernier scale and comparative scale, different types of scales are there. But as per our syllabus, we have only two types of scales are there. So today we are going to discuss plane scale and diagonal scale. So first of all, we see what is the importance of scales. So scale mean we know that a length of the scale is 15 centimeter or 30 centimeter. So to measure the length, scale is needed. So this is the scale. But actual thing is, suppose if you are going to construct a big house planning or a big machine component, anything if you want to draw on a sheet, it is not possible to keep actual dimensions. That's why the scales are needed. So big component we can convert into small component and we can draw, or a very small component is there. Example, in our watches, inside small wheels are there. Okay, so that we cannot put on the paper. Why? Because it's very small. That's why we can enlarge it and we can go for enlarging of the scales. So we can increase the dimension or we can decrease the dimensions. So without designing or without drawing, we cannot manufacture any component. That's why scales are very important. So here, as per concern, the scales, one is reducing scale, enlarging scale, and actual scale. Suppose an actual scale is there, 1:1 we can take, whatever the dimension is given, same dimension we can take. Our reducing scale is there, 1:1, 1:2, 1:3, that we are calling here it is scale factor. So by multiplying the scale factor, we can increase the dimension or we can decrease the dimension. Okay, so that is no needed for us. So here in the plane scale itself and triangle scale itself, we will go for first how to calculate this length of the scale. It is very important. So calculation part is half of the calculation and remaining half part is the drawing. Okay, that we will see clearly now. So here first we will go for plane scale. Plane scale. The question is construction a scale of 1:60 to show meters and decimeters and long enough to measure up to 6 meters. Mark on it a distance of 4.7 meters. So this is the question. So here the scale factor is given. A construct a scale of scale factor is given 1:60 and long enough measure up to 6 meters. So total length of the scale is 6 meter is there, and on that 6 meter scale we have to mark the 4.7 meters. So simple logic I will tell today. So this is given data. Okay, and we must go for meters and decimeters in the form of meters and decimeters. So assume this scale. So first we must go for conversion of units is very important, and how to calculate this length of the scale, full length of the scale, that is also very important. So this is not there in any textbook. So this logic I will tell you. Suppose we want to calculate first length of the scale. So you must focus on length of the scale. So length of the scale is equal to, the equation is scale factor in the shortcut form SF scale factor, or sometimes in some books he may call that a scale factor, or we may call it is refractive factor. Refractive factor. So scale factor into maximum length to be measured. Maximum length to be measured. Okay. Maximum length to be measured. So this is the equation. So either in plane scale or diagonal scale, this is the constant. This is constant. So plane scale, length of the scale is equal to scale factor into maximum length to be measured. So come to here, what is scale factor here is given? Scale factor is given 1 is to 60. 1 is to 60. Okay, 1 is to 60. So into what is maximum length measured? It is 6 meters. 6 meters. Okay, same thing. Whatever the given data is given, that we are writing here. So this 1 is to 60, how can you write? This we can go for 1 by 60 into 6 meters. This meters we convert into mm. So in whatever the dimensions is there, in any question is there, first you convert it to mm. Why? Because drawing is in all dimensions are in mm. So first you convert mm. So 1 meter is equal to 1000. 1 meter is equal to here I am writing 1 meter is equal to 1000 mm. 1000 mm. So you must by heart all the values here. So conversion parameters are very important. So 1 centimeter is equal to 10 mm, 1 meter is equal to 100 centimeter, or 1 meter is equal to 1000 centimeter, 1 feet is equal to 12 inches. Like that, feet, so yards, so kilometers, so everything. The small units to big units, so everything, all the units you must by heart. Okay. So 1 by 60 into 6 into 1 meter is equal to 1000 mm. So we are converting into mm. So into 1000. So divided by, if you say this, how much you will get? So here 1 by 60 into 6 into 1000. So 6 to 6 0 0. So you will get 100 mm. Okay. So here length of the scale is equal to 100 mm. 100 mm. Now directly you can take the scale. Directly you can take the scale, and from 0 to here 10 mm, 20 mm, 30, 40, 50, 60, 70, like that you can go for up to 100 mm. Okay, 100 mm length of the scale you can take here. So I will draw here. So take a so 100 mm length of the line, 100 mm length of the line scale. Okay, so this is A and this is B. And in plane scale, you must remember that the height of the scale is equal to 10 mm. 10 mm. Okay, and draw the parallel line and join this line. So this is full length is equal to 100 mm, and this height is equal to 10 mm. Okay, A, B, and this is C, and this is D. Assume that A, B, C, D. This is scale. And after completion of this, you must go for how many parts you have to divide scales. It is very important. Number of parts are very important. So before dividing the scale, first you check the what is our needed. What is our need? We must mark on the scale 4.7 meters. So already 100 mm means that meters we converted into mm. So 4.7 means roughly what you have to do, just assume that it is 4.7 here, it is 5. 4.m means 4.7 means it is around 5, and plus 1 part. Total you go for 6 number of parts. It is a constant method. Suppose 5.3 is there. Roughly you assume that it is 6 plus 1 part extra. So you can go for 7 equal number of parts. Okay. So like that, this is the equation. So any question, what you are going to mark, just to see that problem and make it round figure, and plus 1 you add it. So then you will get next figure. So 6 number of parts. So here A to B length of the line you must go for divide into equal number of 6 parts. So from here, from one end draw a inclined line, and with compass take any radius and cut this line into equal numbers 1, 2, 3, 4, 5, 6. Okay, we need only 6 equal number of parts. So join this last 2 point to this last 2 point and project all the lines. So you will get a 6 equal number of parts. Okay, 6 equal number of parts. So this is 1, 2, 3, 4, 5, and this is 6. Okay. Now you, or it looks like a scale, just you give the, from the center point to draw the line like that. Leave the one portion and draw the line, leave one portion and draw the line. It looks like a scale. It looks like a scale. And leave the first portion, and start. This is the 0, so this is 0. So this is 0 0.1, 2, 3, 4 and 5. So now these are all meters. So 1 meter, 2 meter, 3 meter, 4 meter, 5 meter, 6 meters. Okay. Like that you have to go for, these are all meters. So I am writing here, this is meters. These are all meters. And this is 1 meter is equal to 10 decimeter. 1 meter is equal to 10 decimeters. Okay. So first portion is decimeter. Decimeter. Okay. Decimeter. So here we give already 0. So 1 meter, this is 1 meter. So 1 meter is equal to 10 decimeters. So this first portion you have to go for 10 divisions once again. So this is the center point is 5 and last point is 10. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So first portion we divide into 10 equal number of parts. Why we went for 10? Why? Because 1 meter is equal to 10 decimeters. Suppose here yard is there. 1 yard is equal to suppose here feet is there. 1 feet is equal to 12 inches. So first portion we divide into equal number of 12 parts. Okay. So here meter is equal to 10 decimeters. So then you go for why? Because why he is asking in meters and decimeters. That's why we are going for only meters and decimeters. In question itself it is there. What he asked in questions? Construct a scale of 1:60 to show meters and decimeters. See here, meters and decimeters. So he asked it in meters and decimeters. That's why first we meant for meters and 1 meter is equal to 10 decimeters. So we were going for decimeters also. Okay. So 10th part of this meters is decimeters. So now what you have to do? So divide this first portion also 10 equal number of parts. Either directly you can divide, or you can go for indirect method also you can divide as your wish. You can go for any method. So this is also same thing. Join here, and these are the sub parts. So 0, 5, 10. So what we have to measure here actually? What we have to show here? To show or mark on the scale 4.7. So 4 meters, 7 decimeters. 0.7 means in this 10th part. So 4 meters, 7 decimeters. So 4 meters means 1, 2, 3, 4. Okay. Here 4 meters. So from here draw the line 4 meters and 0.7. So in this decimeters 5 is there, 6, 7. Where is the 7th part? This is the 7th one. So from the 7th line draw the line and draw a measurement line and give the marking with HP pencil, and here you write 4.7 meters. So 4 meters, 7 decimeters actually this is. So this is the scale. Okay. So in examination you must write this all the data, how you are calculating and how much length of the scale you are getting. You must clearly write in examination with pencil. Okay. After completion of this portion, then you go for this problem. So somebody they are not going for this all the solutions directly. They are taking 100 mm or something and drawing the scale. So like that, if you are going, you will get only 50% of the marks. So entire engineering graphics or engineering drawing subject, only scales are allowed to write or to solve the problem. Remaining for all the questions, just you are writing question to answer, only drawing. But especially in the scales, you can write, you have rights to write the calculation of length of the scale. Written work is there. So that's why you must calculate it first and then you go for these scales. Okay. And next class or next video, we go for diagonal scale. We go for 1 or 2 problem for diagonal scale. Okay. So please subscribe and share. If any doubt is there, you comment me, drop in a comment box, and please like the video, and thank you for your support and encouraging me. So next class we go for why, because this is not there in the any textbook. If you see here, so 4 plus 1, and if you are making around 4.7 means around figure you are making 5, and then you go for 6. Like that, any problem is there, any problem you can solve by using this. Okay. And one thing you remember that here in plane scale, height of the scale is only 10 mm. These two are important, and the length of the scale we know already how to calculate length of the scale. Okay. So thank you. Thanks once again.